Hello. In this video, we consider earth magnetism or terrestrial magnetism, or also known as geomagnetism. We all know that a freely suspended magnet will be always aligning along the north-south direction. This is the directional property of a magnet. Now, based on that, we got that magnetic compass is made to find the direction, and that is used in Mariner's compass also. Now, why that freely suspended magnet aligns along that particular direction only? That search reached the portion where our Earth itself is acting as a huge magnet. The reason for why Earth is acting as a magnet is not been clear till now. There are many theories here. We are not going after those theories. Now we can assume from the measured quantities and all that Earth will be having a huge bar magnet aligning along this particular direction, with its north pole here and south pole here. And this magnet is responsible for the magnetic field on the surface of the Earth. Now, to study certain things about this, let us consider this is the geographic axis of Earth, axis on which the Earth is rotating. And if you suspend a magnet freely in air, it is found to align along north-south direction, but it is not exactly along the geographic north-south. It is little bit tilted from there towards the westward direction. That this is the alignment you can find. And that axis I can consider the magnetic axis of Earth, with the magnetic north here and magnetic south over here. This magnetic north and south is named after the freely suspended magnet's alignment. Its north pole will be always looking towards the geographic north, and its south pole will be always looking towards the geographic south. The reason for that is the Earth magnet will be having its south pole over here and north pole over here. And therefore, you can find that the Earth magnetic field, it is starting from the north pole of the Earth magnet and going to the south pole. Based on that, you can find that Earth magnetic field lines will be coming outward from the ground, the magnetic south pole, and going into the ground at the north pole. So the direction of magnetic field is actually from geographic south to geographic north, if you compare that with the geographic axis. So these are all very important points to be noted. Now, this is geographic axis and this is magnetic axis, and this is magnetic equator. That point is coming along this way, and this is geographic equator position. Now here we can consider 2 points, that is geographic meridian. Meridian, geographic meridian. What is geographic meridian? This geographic meridian is actually a plane connecting geographic north and geographic south. A plane connecting geographic north and geographic south. It's a vertical plane. That's called geographic meridian. Then magnetic meridian. Magnetic meridian. It's a vertical plane connecting magnetic north and magnetic south at any place. Okay? So, geographic axis, magnetic axis, geographic meridian, magnetic meridian, and how the magnetic field lines are going. Now, based on this, we can find that the magnetic field around the equator is coming around 30 micro Tesla around, and poles it is found to be 60 micro Tesla approximately, and these values are coinciding with the theoretical values of axial field and the equatorial field. For this particular magnet, the poles are coming as the axial points and the equator point is coming as the equatorial point. And axial field is found to be equal to twice that of the equatorial field. And that is the value you can calculate, and we found it like that. So, we can assume that the Earth magnet is a bar magnet situated along the magnetic axis of Earth. These are the basic points of the terrestrial magnetism.